Hello everyone, today we will discuss about regression modeling. So, regression modeling is a fundamental concept in machine learning and statistics. It involves creating a mathematical model to predict a continuous dependent variable based on one or more independent variables. So, here we will cover two topics, that is the estimate. First is the estimation model evaluation, then we have the stepwise regression. So, first we will do the estimation model evaluation, that is using Python. So it refers to accessing how well a regression model predicts continuous outcomes. So this is crucial to ensure the data is accurate and reliable before using it for decision making or prediction. So here are some common evaluation metrics. So first one is mean absolute error, that is mean absolute error, that is also known as MAE. It is the average of the absolute difference between predicted and actual values. Then we have the mean squared error, that is MSE, the average of the squared differences between predicted and actual values. Then we have the root mean square error, that is RMSE, the square of the MSE which provides error in the same unit as the dependent variable. Then we have the R squared, so that explains proportion of variance in the dependent variable that is predicted from the independent variables. So now let's look at the code. So first we will import numpy as np. So we will import the libraries from first is the numpy as np. Then we will import pandas as pt. Then we will import train test split from sklearn model selection. Then we will import linear regression from sklinear model. Then we will import mean absolute error, mean squared error, and R2 score from sklearn matrix. And then we will import matplotlib.pyplot. After that we will generate a synthetic data. For the uh, for that we will first add the features, and then we will target it with some noise. After that we will do the splitting of data into train and test data. Then we will train linear regression models, and then we will make the prediction, and then we will evaluate the model and print evaluation matrix. Plot actual versus predicted. Plot actual versus predicted. So next, next we have the stepwise regression using Python. So stepwise regression is a method of selecting the most significant variables in a regression model. So it involves adding or removing predictors symmetrically based on statistical criteria like the p-value, that is AIC AIK information criteria, or BIC Bayesian information criteria. This helps in building a model with only the most relevant features, reducing overfitting and improving interpretability. Then we have types of stepwise regressions. So here are three types of stepwise regression. First is forward selection, then we have backward elimination, then we have bidirectional, that is the stepwise. So first in forward selection starts with no predictors and adds the most significant one at each step. Then we have backward elimination, starts with all predictors. So then we have backward elimination that starts with all predictors and remove the least significant one at each step. Then we have bidirectional that combines forward selection and backward elimination, iteratively adding or removing predictors. So then there is the explanation of the code. So first we have the data set. We use the diabetes data set to demonstrate stepwise regression. And then we have stepwise. So the function iteratively adds or removes predictors based on their p-values. So predictors with the p-value below threshold in are added, while those above thresholds out are removed. So final model, after selecting the most significant features, we train a regression model using only those features and summarize the results. So now let's look at the code. So here is the code for stepwise regression. So first we will import the install necessary library, that is the stat models. We will import it using pip. Then we will import pandas as pt. Then we will import numpy as np, and then we will import statmodels.api as sm. And then from sklearn.database we will import load diabetes. So it is the data set we are using. So first we will load the data, then we will add a constant for intercept, then we will do the stepwise regression function. So After that, we will perform a forward backward feature selection based on the p-value. So next we'll perform stepwise regression, and then we will train final model with selected features. So now let's run the code. So here is the output with constant with p-value, bmi, s5, bps1, s2, and these are our tables. So standard errors, assume that the covariance matrix of the errors is correctly specified. We have here all the data we needed. So that's it for the video. I hope you understood the topic. Thank you.